In this video, I will explain how to calculate distance and displacement. So in the field of physics, distance and displacement both measure length, but they do so in slightly different ways. So let's start with a quick definition of each. We say that distance is the total length of the path traveled by an object, but displacement is the shortest straight line distance from the initial position to the final position, including direction. So to understand how to calculate both distance and displacement, I have two examples for us to work through here. So let's check out our first example. This says, Sally walks 100 kilometers to the east, then turns and walks back 20 kilometers to the west. Find her distance and displacement. So let's sketch this out. So let's say here we have Sally. She walks 100 kilometers to the east. So let's say 100 kilometers. Then she turns and walks back 20 kilometers to the west. So once she's right here, she walks back 20 kilometers. So her distance is simply going to be the sum of the length of the path that she traveled. So that would just be 100 plus another 20. So her distance is going to be 100 kilometers plus 20 kilometers. So let's write that down. So when we add 100 kilometers plus 20 kilometers, that turns out to be 120 kilometers. Now her displacement, that's simply the difference between her final position and her initial position. So if this is her initial position, her final position where she ended up is right here. So what is this distance right here? Well, she went 100 kilometers east, and then we have to subtract the 20 kilometers where she backtracked and went west. So 100 minus 20, this point right here would be 80. So in other words, she's 80 kilometers away from where she started, or she is displaced by 80 kilometers. And we can also specify that it's 80 kilometers to the east of where she started. So let's write that down. So her displacement is 80 kilometers east. Okay, now let's take a look at our second example here. It says, a hiker travels 2 kilometers north, then turns and travels 4 kilometers west, then turns and travels 6 kilometers south, then turns and travels 4 kilometers east. Find his distance and displacement. So let's go ahead and draw this out as well. So we have some traveler, and it says he went 2 kilometers north. So let's draw 2 kilometers north. Then he turns and he travels 4 kilometers west. So let's draw that. 4 kilometers west. Then turns and travels 6 kilometers south. So let's draw that. So 6 kilometers south. And lastly, he turns and travels 4 kilometers east. So 4 kilometers east. So let's write 4 kilometers right there as well. So first, let's find his distance. Remember, that's just the total length of the path that he travels. So that's just going to be this 2 plus 4 plus 6 plus 4. When you add all those together, you get 16 kilometers. So let's write that down. So his total distance traveled was 16 kilometers. Now his displacement, that's just going to be the difference between his final position and his starting position. So if he started right here and he ended, let's say right here, let's make a little dot. What is this distance right here? Well, we know that he traveled 4 kilometers west and then he came back and went 4 kilometers east. So he ended up in the same horizontal position. And we know that he went 2 kilometers north and then 6 kilometers south. So if this total distance on this side is 6, let's say this is 6, and we can subtract the 2 right here where he went north, then this remaining distance right here is 4. That's just 6 minus 2. So what we can say is that he is 4 kilometers south of where he started. So let's write that down. So his displacement is 4 kilometers south. So those were just two quick examples to illustrate the difference between distance and displacement. Just keep in mind, distance, that's the total length of the path traveled by an object, and displacement, that's just concerned with the distance between the initial position and the final position, and we also specify the direction of the displacement.